Hello guys, in this video we'll be learning about using voltage digitally. Let us see the main key idea behind it. We encode only one bit of information. There are two values which can be either 0 or 1. We'll use the same uniform representation for every component and wire in our digital systems. Let's see the first attempt. We simply divide the range of voltages into two subranges, just like shown on the screen. We divide it to two subranges, one range representing logic 0 and other range representing logic 1. Pick some threshold value VTH to divide the ranges into two. When V is less than VTH, it is interpreted as logic 0, and if V is greater than VTH, it's interpreted as logic 1. Let us see the observations now. It is not workable on practical grounds, as to get the accurate value of voltages at the threshold is inexpensive and more time consuming. The problematic part of this is the difficulty in interpreting voltages near threshold. It can either be VTH minus E or VTH plus E. You can see that interpreting logics near this area is really difficult, where E is a very small value. So we can say that this is not precise. We will now introduce two voltages in our attempt 2. In this, we will be introducing two threshold voltages, that is VL and VH. You can see that there are two threshold voltages, VL and VH. Now, if V is less than VL, it is logic 0, as shown here. If V is greater than VH, it is interpreted as logic 1, as shown here. If V is between VL and VH, it is called the forbidden state or forbidden zone. A particular system can be interpreted a voltage in the forbidden zone as either 0 or 1 and is not even required to be consistent in its interpretation. In fact, the system is not required to produce any interpretation at all for the voltages in forbidden zone. Now, how does this help us? How does using two threshold voltage help us? Now we can build a voltage to bit converter by using a gain op amp. And the reference voltage somewhere in forbidden zone to decide the given voltages is above or below the threshold voltage. The reference voltage need not be super accurate. It could be generated with, say, a voltage divider built from low cost of 10% accurate resistor. The reference could change slightly due to operating frequency or power supply voltage changed. We only need to guarantee the correct behavior of our converter below VL and above VH. This is a good representation.